Hi everyone, I'm Martin and welcome to another excellent edition of Astronomy for Beginners. It's been a long time since I've done the last video guide. Obviously I had a bit of issues with my internet and I managed to change my internet now. So now I'm up and running, things are going okay now, and I'll be making more video guides from now on. Obviously weather's been bad lately and it's not been a very good few months for astronomy at all. As you can see for myself, you know, you've got the rain, the wind, autumn is here, weather's bad, and it's been really shocking for the weather. So obviously, as you guys can remember, I did a video guide based on the Equinox 6 and who it is. As I mentioned before, again, this is a second-hand telescope that I bought from a second-hand shop, and probably a very good buy. It's actually been the best buy I ever bought, and really happy with the results that I've been getting from this little scope. Regardless of the weather, I have managed to image with this, and I'm absolutely quite impressed. Now, as you can remember, way back, about a few months ago, is that I did a guide on able to fit a focal reducer and field flattener onto this telescope. Now obviously the telescope itself is an f6, which is reasonably fast, but okay, it's got a good wide field of view, but if you've got a very small CCD chip, or you know, where you've got limited size and you really want to boost that image, you know, trying to get as much of the image you want to get, like a galaxy or nebula, and you really want to get as much as that nebula or whatever into the chip as best you can. So obviously I did a guide on fitting a 0.6 times focal reducer, and obviously, as I mentioned before, I did quote back that there's no guarantee that it was going to work. So I have tried it and used it, and believe it or not, it didn't work. Now, apologies for the ones who purchased. I hope you haven't purchased anything, but I did let you know, to give you a heads up if it works or not. Now, obviously now I've found a way to do it, and what happened is that the 0.6 times focal reducer, being short focus as this refractor is anyway, it could not come into focus. I finally worked it out that the actual field focal reducer needed to be somewhere in the region at this point for it to go and achieve focus. So basically the tube was too long, for that the lens element to bring into focus. So I found myself, oh no, there is no way to upgrade this by any means. But luckily, went to telescope service. I got in contact with them. Really helpful people. They're a German retailer. They did say, look, you can get a focal reducer, and it's a 0.8 times. Believe it or not, it's their own branded model. It's the only focal reducer you can get for this scope, for the Equinox 66. And they give me a good quote, they give me a good price, €175 for the focal reducer. I'm going to show you now an image that I've taken with this scope. Unfortunately, it's not a stacked image. It's basically, I've just done a single point image. Because the weather's been so bad, I could not collect as much frames as I liked, which is rather a bit disappointing. But it proves that one thing, that this focal reducer that I bought from telescope service had worked. So basically now, as well as this scope now can be an f6, this telescope will now be able to perform at an f4.8, which gives me a very good wide field of view for most DSO targets. Particularly if you want to try and image the Rosetta Nebula, obviously that's a really big nebula, and you want to get as much of that nebula in that field of view of your small chip CCD cameras. Now, bear in mind that the f6 is good enough if you've got a DSLR or you've got a CCD with a very good wide field chip. And I'm talking round about a chip size, a decent chip size for a CCD in the region of something like 12 millimeters in sort of width-wise and so forth. Between 12 or 25 millimeter is a really good decent sized chip. Now obviously I'm using the Orion Starshoot G3 camera, and it's got a very tiny chip, so that's the reason why I wanted the photo reducer. So what I'm going to do now, I'm going to show you the image of a picture I've taken of M57, which is the Ring Nebula. I started off something quite easily seen and visible. It's only a few seconds exposure. It's not particularly spectacular, but it just proves one thing: it gives you the true field of view of what you're actually getting through this scope with the field reducer. I would like to have used a different size, a different DSO to sort of match a proper an image scale, so it gives you a general idea on how much this field reducer. And then later, straight after that, where I'm then going to proceed how to fit this field reducer from Telescope Series. Hi everyone, I'm going to show you the Equinox 66 image of M57 using the Telescope Service field flattener and photo reducer. It is actually a 0.8 times, and basically this is what I've got. Now here's the image. Okay, this was taken from the Orion Starshoot G3 camera. It's coloured. This is only a single image because the weather's been so bad. I managed to capture a few frames, and this basically is a 2-minute exposure of the Ring Nebula. Now, as you can see, it's not been stacked. I've not added any dark frames or bias frames or whatever, and basically you can see a lot of heat spots and all that. Alright, you can see all the false colour. Those are just hot pixels in the image. That's what happens if you do not stack dark images. You get this interference and noise. Now, I'm aware that the CCD, the Orion Starshoot G3 camera, does have cooling, but this was taken on a warm night, start of autumn, and it was relatively warm. The camera can cool down to below 10 degrees ambient temperature. It's not exactly a powerful fan, but you can eliminate the process with these hot pixels by taking dark frames and then you stack it together. But as you can see, the main purpose of this image is to show you how wide that field of view you can achieve through a small chip camera, because the G3 is quite small, and you can see if you look here where the crosshair is highlighted, that's where the Ring Nebula is situated. So as you can see, it's quite a big star field all the way around, and that is the actual view you're getting from that field reducer and field flattener. Now obviously the photo reducer has helped a lot widen the field, and also all the stars, even to the round the edges, are all not elongated, they're all pretty sharp, which shows you that the field flattener and the photo reducer is doing its job. This is what you need if you're taking long exposure images like this. You're going to need a field flattener at least if you want all stars to be all pinpoint and round. Now, it's no fault in the camera itself. It's usually the optics on the lens systems or on
on the refractors, where the refractor, when it refracts the light, bends the light, and basically around the edges the stars appear to be sort of elongated. It's not, don't get confused with coma. Coma is a different effect which happens in Newtonian reflectors, but obviously you get this curvage from the refractor lenses. Alright. The field flattener will prevent all the stars from being sort of elongated and stretched, and obviously the focal reducer will help to widen the field of view and give you higher and faster optics and quicker exposure times. Now this is only 2 minutes, and as you can see the colours within the stars. Ignore these pixels here; these are just hot pixels. But within the colour of the natural colour of the stars, and even the nebula itself, you can see the hint of green, red, yellow in there. This is only a 2-minute exposure, which is not very long. I couldn't achieve anything higher than that because it was fitted onto my brand new Ioptron mount, which has performed really well. However, again, with most mounts, doesn't always guarantee that the mount's going to work straight out of the box. Also, you have to do a few tweaking, you have to do a few adjustments to try and get it right. That's the way it is with mounts, and that's what you have to do. You have to get used to the equipment. Obviously, the Ioptron being the first night out with the new Equinox 66, again, you're going to have to take practice. The more you practice on your equipment you start using, the better you'll be more confident in using this equipment, and you will get better in resulting better images. Now, as you can see here, the 66 has revealed a lot of detail, and I'm quite impressed on how much detail you can achieve. If I could try and sort of zoom in there so you can see the nebula just a little bit more. You start to see, you can see the nebula now as I zoom in. Now obviously be careful when you're cropping images, because there's no guarantee that, you can start to see now the image will start to get all very pixely. That's obviously when you start zooming in the image, it will start to look very pixely, and you see the little squares and all that. Again, you can just clearly define the ring with the green little nebula in the middle, the green hint of green and the hint of yellow and red. Alright, this is only just a raw image. It's not been stacked, it's not been processed. That's the image you get. And again, I'm quite impressed on what I've achieved through just a small amount of exposure. Alright, so it's gone a long way. The Equinox 66 is quite an amazing little scope, and the amount of level of detail you can get from just a short exposure like that is quite impressed me. Now obviously if I had more frames and I stacked them more, then it would have been better. Now ideally when you're taking nebulas, especially planetary nebulas and globular clusters, you don't really need a focal reducer, because you really need to boost the image scale up, so that your ring nebula will stand out a lot closer, be a bit bigger, you'll start to see the structure and all that. Ideally you use a focal reducer for big DSOs like the Rosetta Nebula, the Orion Nebula, and big things like that, or the Andromeda Galaxy for example. So that's when you start going to need a focal reducer to try and boost that field of view, so you can get much of the nebula or the galaxies you want to image. Now, also we're going to go back to 100 times the actual size of the image. Alright, and you can see now, compare the results. Now, I'm going to compare it to show you now what I use. Basically, there's a little handy program that I found out on the internet, and you can download it, and basically I use this program, which I use as a guide, so that gives me a sort of rough field of view if I'm using a certain amount of equipment. And this is the program I use, and it's really fantastic. It's done by Ron Wodhaskis, and it's called the CCD calculator. It's a freeware. If you type in that, type in Ron Wodhaskis CD calculator, you'll be able to access and basically upload this. Basically what's happened here is you've got like series of menus which you can select. Believe it or not, the Orion Starship colour, you get different types of telescopes you select. So you can select different types of telescopes along this menu. Or ideally, if you can, you can create your own telescopes. And basically what you do is you just basically click add, type in what the name of the scope is. You then adjust the aperture, the focal ratio, what it is, and if it's a Barlow lens or whatever. And basically what this handy feature can do is it will calculate the exact field of view you're looking at when you're using a certain camera or you're using a certain CCD. Again, you can do this exactly the same format for other CCDs. Alright, I've got a list of things like that, and you can click on quite a few, like the QHY8L CCD or the QHY9. Again, providing you've got the specifications of that particular camera by its pixel size, the array size of that camera, and what sort of binning mode it's at. Alright, if you just get these, the pixel size and the array size is basically the chip size in millimeters, and the pixels is usually, you can find that in your instruction manual. And basically, once you've got these calculations and you've added them onto your list, you can then just sort of click through different size of options. So if I want to click on the Equinox 66, so I've got my menu there. Basically, with the QH9, you can already see that if you fit a wide field camera, if you look in this screen here, basically this border here all the way across represents the actual camera chip size. So basically, if I fit the QH9 CCD on the 66, you have got a massive range, and I mean it's massive field of view, which can be a bit of a good thing or a bit of a bad thing. Now, obviously, if you click on series of other cameras, now if we were going to compare it with the Orion Star Shoot G3 camera, if we try look for it, it'll take some time. Okay, fit the Orion Star Shoot colour, and basically with the 0.8 times photo reducer, because it's got a reducer, this is the sort of field of view you're getting. Now, if you can change the field of view, say you've not fitted a field flattener and a field reducer, you just had it as standard. So F6, you can already see this boundary now reduced to size. So basically, this will be the exact size of your Orion Star Shoot camera. Again, you can click on different. If you click on this part here, this will show you a series of diesel images which you can select, alright, and gives you a general idea on the actual image scale. Now if we go to M31, this is what you're going to get if you're trying to image Andromeda Galaxy through that particular CCD, and already this border here can only cover a small proportion of that galaxy. So basically, the entire field of view is taken away from the central core of M31, which is okay, it's alright ideal as a first image, but when you get really into the hobby of imaging, astral imaging, you can't really, I wouldn't say an image like that would be great. I mean, ideally you want the image to be completely in that box for the camera. if using a 0.8 reducing, alright, if we change the Barlow or reducer size to 0.8, which is 0.8 times, again, that box is now widened. As you can see for yourself, it's helped a bit, it's widened the field of view. Again, still not adequate. So obviously the 0.8 times field reducer, field flattener, it's not particularly great. Now if the 0.6 did work, which I changed to 0.6, that would have been okay. But again, Andromeda is a massive object, it's so big. Even with this camera here, on the G3 camera, it's just not sufficient enough to get Andromeda. But there's no hardship, not all cameras are perfect. If I was, to be honest with you, if I was taking the image of Andromeda, if I didn't have a wide field CCD, a DSLR would be the perfect choice to get this object. Now, if we go back to the 0.1, alright, that's normal. That's basically without the focal reducer, and we try a really good target, M42. Another firm favourite, the Great Orion Nebula. Again, now what you see now is you can see the box. Orion Nebula just fits in there. Okay, it's not brilliant. However, adding the focal reducer to 0.8 times. Now that is a decent size image. Now I managed to get the complete nebula with M43 and M42 together. Alright, a little bit of the Running Man Nebula on the top, but again that would be an ideal shot for taking that image there. So that looks a lot better, and it just proves that the field flattener and the focal reducer has helped a lot here. And basically this is what I'm trying to explain to your guys, that fitting these simple optical devices helps massively, putting that image scale up so you get the best maximum view of that particular object and be able to take an excellent image of Orion, for example. I mean, that's a pretty good picture, that. But again, the 0.8 times only seems to work really well with the Equinox 66. Again, always check with your existing telescopes. Every telescope is different. Some focal reducers may work, not all of them do. So obviously check very carefully, ask around telescope retailers, ask people in astronomy clubs or meet up with them, ask them a few questions. What sort of focal reducer or field flattener is ideal for that particular scope? Believe it or not, sometimes you find that there may be someone out there who owns that particular scope that you've got, for example. And again, just ask around retailers and all that. Again, bear in mind, this new Astronomy Press CCD calculator is only a basic guide. But if we go to M57, this is the exact view that you get from the camera, using the focal reducer, using the same telescope and the same camera itself. Now, obviously, this is just a rough guesstimate, but I'm just going to go back to compare. And okay, if we go and check the image, I would say that is pretty much pretty close, really. Right, that's pretty close. Alright, it's not perfect, but it's pretty close. Alright, so it is actually a very good general program. Alright, so it does give you a good guesstimate on the actual image scale you're looking at. Alright, but again, very handy little tool. Seriously recommend everyone to obviously download this Ron Rodsky's CCD calculator. Again, it's a little handy feature, and It's so simple. You just add a few your specification of your telescopes in there on this box there, add a few in the cameras, and then away you go. Alright, so it's pretty good. Alright, so again, it's not perfect, but it goes a long way. Now, basically what we're going to do now is we're going to go over now and show how to fit this telescope service 0.8 field flattener and full screw juicer. So we're going to go over there now. Fantastic little scope. It now just proved itself. It's worth the money. Being a short focus refractor and a very good ED doublet. Very costly telescope to buy. Buy brand new. It's retailed around about £319 in a very good astronomy shop. However, I managed to get this for literally €70 second hand because the owner thought it was just a toy, and he just tried to get rid of it. He had no case, and basically I said, well, I'll snatch it. Realising what I bought was such a fantastic buy, and it just proves that small equipment is good for astrophotography. And again, as I said this before to your guys, is that with astrophotography, you do not need very big telescopes. You know, as long as your mount, the mount is the key to astrophotography. As long as it's tracking, mount is equatorial mount. It has a built-in polar scope, so you can do polar alignment. And then ideally, if the mount has a SynScan or some kind of go-to function to enable you to track the objects. Again, there are many EQ mounts out there. Skywatcher, very good branded EQ mounts available. Alright, and you can get the EQ6, which is the top of the range one, all the way down to the very basic of an EQ3. Now, an EQ3 would work ideally with this scope, being quite small. It worked perfectly. Again, EQ5 is probably the better budget one, I would suggest, and even better to that model is the HEQ5 mount, which is probably the best good all-rounder. The EQ6 and the NEQ6 mounts are really ideal for bigger scopes. You know, they're very heavy-duty mounts, and they will, you know, they're fantastic for the value for the money. Now, obviously with this telescope, when you first got it, it comes with this focuser, which is a 10:1 focuser, and here is, as you must have seen it on my last guides, is that this has some kind of scat thread. Now, the scat thread is very easy to take off. You just unscrew this point here and it all comes apart like so. It does come out eventually. And basically it leaves this point here and you just get rid of it. Now, one thing I've noticed is that this is a 2-inch focuser. But because where's this when this Equinox 6 is designed, it's only you can't put 2-inch format in there, even though it can fit it. So ideally what you're looking for is you're looking for a SCAT or SC to M48 thread adapter, which basically you can get this from Telescope Service for about €19. Alright, and basically this is the thread of the SC thread, which screws onto this point here, and then you have a little bit of a thread here, which is the M48 thread. Basically you screw this in there like so. Alright, this adaptation will give you a 10mm clearance. Alright, so once it's fit flat flush like that, it's done. This will now enable you to fit 2-inch format. Alright, as long as it's an M48 thread, you can fit in a 2-inch holdall adapter, which you can fit a 2-inch mirror diagonal or eyepieces. And what we're going to go now is this one. You must have seen these before. This is the a 2-inch and 1/25 self-centering adapter. Now, obviously Orion do these, and Antares do these sort of adapters. It's a self-centering adapter, and basically what that does is enables you to fit 1.25" fitment of eyepieces, or believe it or not, obviously the Orion G3 CCD camera, which has a nose piece which will slot into there. Very good little adapter. The self-centering adapter is ideal for putting CCDs with the 1.25" nose pieces, or you can fit smaller 1.25" fitments like a small diagonal, or eyepieces or Barlows. That's the reason why I got it. It's a very good adapter. Be aware, stay well away from knockoffs, particularly around eBay. Alright, there's a lot of these adapters out, and there's a lot of knockoffs out there. Always look for an Orion, an Antares one, or a telescope service one. These will probably be the best choice. Alright, they're guaranteed to work, they're not knockoffs, very good high quality, and they do self-center as stated in their websites. Because a lot of the other ones aren't. Alright, and they're absolutely rubbish. But get the proper ones. TS, Antares and Orion that only do these self-centering adapters. Alright, keep away from eBay. There's a lot of knockoffs out there. They do not work. And obviously Simon Fletcher can also vouch for me on this one, because he has bought a similar knockoff and it was absolutely rubbish. With these ones, they do self-center with their little tight front screw in here. Alright, you can screw it on there like so. They do self-center properly, and because they're particularly useful, like when you fit a laser collimator on a reflector. The cheaper ones don't. They do not self-center at all. They're absolutely rubbish. Don't waste your money. Don't buy cheap. Buy good stuff. Guaranteed. That is the promise. Now, the reason why I got this is I'll explain later on. Basically what we're going to do now, we're going to move over to this. This is the photocal reducer, which is the 0.8 photocal reducer. This you can only get from Telescope Service. You can find it on their website, and basically this is the only photocal reducer and field flattener that works for the Equinox 66. Now obviously when you buy your telescope and you want to try and look for a certain specification, see if it fits, because not all field flatteners and photocal reducers work, as I found out with my 0.6 times photocal reducer and field flattener. Alright, not all of them work with certain types of telescopes. Unfortunately, Telescope Service came to the rescue and they do one. Now, as they stated before, it's very good high quality. You know, good old dust cap and a screw cap on the side here, like so. You know, I just screw it on there. Again, very good quality. Alright, you can just see the coatings on there. Alright, basically for this to fit, it has an internal thread here, which is the M48, and basically what that does, it screws on there like so. Very simple device, and it screws in just like that. Basically the good thing about this setup with this photocal reducer is that you can actually have this as a permanent setup, so you don't really need to take off anything apart. Alright, so, and again, already fit, and as I noticed, there is a T2 thread here. Now obviously we come to a slight problem again. When I came and got the adapter, it didn't fit, as always. Obviously Telescope Service again came to this help, and they helped me out with this. Again, doesn't cost much. Basically this is an M48 thread with a T2 internal thread. So basically what that does is, if I tilt the self-centering adapter, I then apply this M48 internal thread on there, like so. Basically what that's going to do now is enables me to fit the T2 internal thread to fit into the photo reducer. Alright, and then it fits like so. Now, this now gives me the adapter to fit my Orion Starshoot G3 camera, which is here. Again, with its 1.25 inch nose piece. As you can see, it's already got a nebula filter already fitted, as you can see, so to protect the chip. Now, again, the reason why I did this adaptation little setup not only gives me the ability to not actually have to take anything out, it gives me a nice solid sort of setup. I also like to have this quick release thing where I screw in the adaptation and then I tighten up using the self-cincher like so. Alright, I tighten it up. Alright, gives it a nice tight feel. Alright, and that basically gives me a very good, well engineered setup. Alright, no sort of any free play within this train system. Alright, this optical system is very sturdy. Alright, so I'm not going to get into any problems. Alright, so again, this setup is now already sort of adjusted. Now, also, what I did is worked out that the Orion Starshoot G3 camera requires a certain amount of back focus. Now, as I explained to a lot of forums, you know, especially our forum, Astronomy for Beginners, is that when you fit any field flattener or field reducer, you need a certain back focus. So basically, of this certain gap you need for the actual field flattener or photo reducer to work. Alright, so you get the maximum effect on the stars being corrected. So you don't get the curvature, you get the correct field of view, and basically you need that adjustment perfect. And you allowed around about 1 degree plus or minus of error. Alright, so once you're within that 1 degree error plus or minus, you will get the maximum effect for that field, the FF or FF, to give you the maximum effect and for it to work properly. Now, as I did a bit of maths. Basically, I've realised that with the nose piece fitted onto the G3, the CCD chip is actually 19 millimeters back focus. For this setup to work, and being the camera being 19 millimeters of back focus from the CCD chip, I basically needed 36 millimeters more to give the ideal 55 millimeters of back focus required for this attachment to work. So basically, from this point here all the way up to the camera CCD, I basically needed 55 millimeters. And with this setup alone, adding the nose piece and on there adds a certain gap. As you can see, the certain gaps here. Now obviously around this part here, it's around about 34. So this adapter here from the self-centering adapter is around about 34. And then I've got this 2mm gap from the nose piece. And then from there, this has given me the perfect back focus. So I've got 36 there, 19 there, giving me this perfect 55 millimeter ideal air gap. Worked out a massive cheat. And basically, believe it or not, I can now get achievement perfect focus. Literally, as I just turn here, about there, I have now got perfect focus at that point there. Alright, straight away, do not need to mess about. I basically lock it from the back, alright, on the back end there. I basically now, all my stars are now perfect focusing there. Alright, so again, worked out massively. As I mentioned before, this does not apply to all telescopes. Every telescope is different in some degree. Alright, so just bear that in mind. But again, do a bit of maths work, find out the back focus of your camera from the CCD chip, and then work out the rest for the field flattener and photo reducer to work properly. As you can see for yourself that the 0.8 fits. Now the 0.6 for this telescope to work, the 0.6, ideally the tube needs to be shorter to enable the 0.6 to work. Unfortunately, this tube is rather small, and so that the 0.6 didn't work at all. Basically what happened there, I could not get into focus at all whatsoever, going backwards and forwards and vice versa, and basically I was just getting nowhere ahead. Luckily the 0.8 does fit, but again, you can get a 0.6, you can get 0.8, you can, you know what I mean, you get different size various photo reducers and field flatteners, but it just depends on the telescope brand. Alright, a lot of these attachments you can get are usually perfectly made for certain f or photical ratios of certain telescopes of certain apertures. Alright, do a bit of research, you can get them. Alright, believe me, again, they're out there, you just got to do a bit of maths work and just check up. Obviously the 0.8 works perfectly with the 66, giving me an f 4.8, which is ideal. It's fast enough, and I can get a good wide field with this camera alone. Alright, so again, I hope this has helped you guys. Sorry for the delay. I did explain later on that I was going to do another guide to back up the plan, see if the part 1 works or not. I hope you enjoyed watching this guide. Please feel free to ask us any questions regarding this video, and we'll look forward to seeing you again with another guide. So again, keep posting those great images, we'd love to see them. Thanks for your support. We've been getting a massive amount of members joining us, and thanks again, thanks for watching, and hope you have clear skies.